everyone, today I'm going to deliver a lecture on deflection calculation by virtual work method or in unit load method for trusses. So it will be focus on only for trusses. So the lecture will be there is some content. So first of all I will cover some topics, which is comparison various type of structural analysis method, which is virtual work method, unit load method, force method, moment distribution method, stiffness matrix method, etc. method for calculating deflection, rotation, moment, shear, etc. So and then I will try to cover the theory of virtual work method or unit load method only for trusses, and last one I'll try to give some examples of virtual work method or unit load method only for trusses. Okay, and the sequentially I will try to deliver lecture on virtual work method for beam, virtual work method for frame, etc. So let's try. So comparison various type of structural analysis method. So we can see here there are 5 structural analysis method. So method 1 is virtual work method, method 2 unit load method, and method 3 force or flexibility method, method 4 is moment distribution method, and last one is stiffness matrix or displacement method. So the virtual work method mainly used for deflection, rotation calculation, and structural type it can be determinate and indeterminate, and it is based on principle of virtual work, and strength is generally method for calculating displacement, and limitation is not used for force analysis. And second one is same as it is unit load method is also main use for calculating for deflection and rotation, and then structure type is determinate and indeterminate both, and it is based on a special case for virtual work, and strength is simple and effective for manual calculation, and limitation only for displacement. And third one we can see the force method, which is flexibility method. It is main purpose for solve the unknown forces and moment, and structure type is indeterminate, so it will be very important, and the based on the it is based on the compatibility and structure flexibility, and strength is good for low degree of indeterminate structure, and its limitation for complex for higher indeterminate system. And number 4 again we will see the moment distribution method. It will be used for solve the moment in the beam frame, and it will also keep in mind that it is type of indeterminate structure only, and based in the joint equilibrium and member stiffness, and its strength is first hand method for continuous beam and frame, and limitation is manual interactive, not for complex geometry. And last one we have been seeing the stiffness matrix method is or we can see the displacement method is generally used for the general analysis, and structure type is both, but it is especially for indeterminate structure based on the equilibrium member stiffness and displacement, and strength is very symmetric, easily program from FEM, which is finite element method based, and limitation is tedious by hard and matrix inverse needed. Now we can see the summary of the table of determinate and indeterminate structure. We can see here the method is given the virtual work method, but we can solve the determinate structure, indeterminate structure, but it is not used for force, but used for calculating the displacement. And we can see the unit load method. It is also determinate. We can solve the determinate structure. We can solve the indeterminate structure, but it is not used for force. But we can calculate the deflection. The force method, which is very important, we can say it is not for calculating the indeterminate structure, but it is for indeterminate structure. It is used for also calculating force. It is also used for the calculating displacement. And then we can see another is moment distribution method, which is also very important. We can see it is not for indeterminate structure, but here we can analyze the indeterminate structure. Used for also calculating forces and used for the deflection. It is not used for deflection. And last one we can see, this is the stiffness matrix method. It is very important because it is used for the computer programming. So we can see the we can analyze the indeterminate structure and indeterminate structure both, and used for both force and the deflection. So we can see summary. Another was comparison table. We can see virtual work method. It is primarily used for the deflection analysis, and type is determinate and indeterminate both, and based on virtual energy and displacement we can mainly calculating displacement. And advantage is general purpose of displacement tool. And unit load, we can see the deflection, rotation, and it is also both determinate and indeterminate, and simply work and displacement walls and easily to apply. And force method, we can see the force is fully analysis force, and determinate it is not for determinate but indeterminate we can analysis, and based on the forceability, compatibility and force, and unknown redundant force, and is suitable for hand calculation. And then we can see the moment distribution method. It is main for moment in frame beam. It is we can analyze the indeterminate structure and moment. It is moment equilibrium, based on moment equilibrium, and main focus on joint rotation and continuity. And it is simple in the first 1 degree indeterminate system. And last one we can see here the stiffness matrix. It is fully analysis for force and displacement, and determinate and indeterminate we can analyze the both. And it is based on the matrix form, which is F equal to KD, which is a force, K it is stiffness, and D is a displacement. And the main focus of the displacement forces, and advantage is based for computer aided large structure. And last one we can see the application of the summary by structure type. If we thinking by structure type, there we can see the simply beam. We can use determinate simply beam. We can use the UDL unit load or virtual work method. In truss, it determinate structure of the structure, then we can use unit load and virtual work load. And then we can see the fixed beam, which is indeterminate. So we have to use moment distribution, force method, and stiffness matrix. The another one, the continuous beam, which is also indeterminate, then we can use the moment distribution and stiffness matrix. The rigid frame, we have to use the analysis the moment distribution method, and force method, and stiffness matrix method. At last one we can see the complex or 3D structure. If we want to analyze that we have to use the stiffness matrix method, which is based on the FEM, which is finite element method. So we can see the first topic has covered, which is comparison variance structure analysis method. Now we can see the theory of virtual work method or unique load method of the truss, only for trusses. So let's see here. This is our the reference I have been taken. This is the book from the Hibler. So we can see the first definition, the method of virtual work or beam or frame. The method of the virtual work can be also applied on the deflection problem involving beam and frame. So since the strain due to bending and the primarily causes the beam and frame deflection, so we will discuss their effect of the first. So you can see here is a formula of the deflection method. Deflection is integration of m into m and divided by ei into dx. So here the some we can see the notation is given here, so you have to write here or keep in mind. So in the same way you can calculating the rotation in the same way. So formula is given here, m into ex. So if you now we will focus on the deflection calculation by force method, by method of virtual work method. So here is the method of the virtual work, another way to representing equilibrium equations by the energy method, which is based on the law of conservation equation. According to the principle of work, if the system is equilibrium is subjective to virtual deflection, virtual work done by the external forces, and it is equal to the virtual work done by the internal forces. So we can see here the external work done equal to external work done equal to internal work done. So where the symbol sigma is used to indicate virtual work. So here we can see for virtual load, we can see the load magnitude is 1 when the applied load is direction of delta causes the virtual internal forces U, and in element B in the direction of del L, and the virtual work done by the external forces, which is sigma WE into 1 into del. So I'm going to here according to the principle of the virtual work, if the system is equilibrium subjected to virtual displacement and the virtual work done by the external forces is equal to the virtual work done by the internal forces. So we can see the virtual work done by external force equal to the internal force. So external force is internal force. We can see here a weird symmetric structure is given here, and one unit load is given in downward, and another deflection is del L is given the UD, and the rotation we can see here the external force is given here. So user this loading condition point we have been seen here. This the point as deflect on an amount of delta L. This is the del in the direction is shown figure. The same load is causes the element B. So this is the element of B we have been seen here with the body of the external extended an amount of del L. This is the del L in direction is shown here. So virtual forces we have been shown. We can see the work is a force into displacement. We know the work W equal to Fs. So in this case we have been shown the external work into force is 1 unit load. So we can see here the 1 unit load, and distance we have been shown here the delta. In this way we can see the virtual work done the internal forces. So we can see the internal force and force into distance. So force we have been used U. This is the force of U, and the distance del L. This is the del L. So in this case we have been found summation of U into del L. Summation of U is the sum of the virtual work internal forces. So TL is in deflection. So in this case, so if we calculate it in equation 1 and 2, so we have been found in external work into internal work. So external work into 1 into del. So we have been found del into L, and U summation of U into D, which we have been getting from equation 2. So in this case we have been found delta equal to summation U into del L. So here all the notation is given here. So you can see deflection of truss due to external load. So we know the from solid mechanics 1P equal to EL. So in this similarly we can use the deflection del L equal to N into L into A into E. So as we've been seeing, the deflection is unit load N1 is given deflection force into displacement N1 into DL into N into DL. So all the notation is given here. I hope the another topic has completed, which is the theory of virtual work method only for trusses. So let's see the last one, which is the example of virtual work method or unit load method for trusses. Okay, so let's. So first of all, I'm going to here. This is our main example, the determinant of the vertical displacement of joint C. This is the structure ABC, or this is the C point of the steel truss is shown below. The cross section of the each area member A equal to 0.5 inches square, and the modulus of elasticity is 29 to 10 to the power 3 KSI. Use the virtual work method or unit load method. So here we have been seeing the determinate truss. We can use the virtual work method or unit load method. For indeterminate truss, we have to go to the flexibility method or force method or moment distribution and stiffness matrix method. So as we have been seeing, this is the pin support or hinge support, and this is the ruler support. So we can see this is the determinate structure. So that's why we can use the virtual work method. If this structure is indeterminate, we have to go to the flexibility method, force method, or stiffness matrix, or others method. Okay, that is done. So first of all, I'm going to how we'll cover this here. I'm just writing here very shortly. So if you go there here, so this is our very shortly how we'll solve this problem. How we'll solve this problem. This is the sequence. So very shortly, if at first we have to find out the reaction and find the angle. So angle between this is the adjacent angle between AB and AF, and find the deflection. Let one unit work is upward, and or if the getting the first slope for one unit keep fit on upward moment, and finding the member forces by calculating very quickly. And I will show how we'll calculate, and then we will show the positive is right direction, and negative is compression. Is tension is right direction, and compression is left direction. Okay, so first of all I will try to the I'll divide this this member I will divide it to one is real force, another is virtual force. So now we'll in calculating this force, how we'll calculate the reaction. So let's see the how we'll calculate the reaction. So we're getting the moment of summation of ma equal to 0 equal to positive. So force is 4 into perpendicular distance into 10, 4 into 10. So I'm just taking here the 4 into 10. So 4 into 10 the perpendicular distance, and 4 into 20 another load is given 4 into 20, and here is a D. We can see here. So I'm just zooming here again. So RD equal to RD into 30. So in this case, in this way we will for the RD equal to 4, which is upward. So we're getting the RD equal to 4 in upward direction. So this is the 4. So in this way we are calculating the summation of f of y equal to positive in positive. So RA plus 4. So as we know, this is the RA. This is the RA, and write on RD equal to 4. So we have been seen here RD equal to 4 is given here 4 RA plus 4. This is the RD value equal to downward. So downward we have been seen here 4 into 4. So we are seen here 4 into 4. In this case we have been found RA value. This is the RA value. Also we are getting RA equal to 4. So this is the real truss. What is the real real force? Real force, that means this force, this 4 keep and this 4 keep will be remain same. Plus will be virtual force. What is the virtual force? Virtual force is one unit load, which is given where the determine the vertical displacement at joint C, where we'll find the deflection. In that point we'll apply 1 unit load in vertically. That's why we are applying vertical load here. So in this sequence we've been seeing find the angle, rotation deflection is here. So that's why I'm just showing here. So you have to keep in mind that this is our given structure. So it will be equal the real force plus virtual force. Virtual force means one unit load. So 1 unit load, if we apply the 1 unit load, what will be happen in this structure? So we'll see. So we have been taking moment is here. So there is a moment is here. So 1 into 20. So 1 into 20 is given here the length. We've been seeing 10 into 10, which is the 20 to RD into 30. This is the RD, and 30 is the total load, total distance. In this case we've been found RD equal to 0.67. This is the 0.67 in downward. In the same way we will calculate the Fy equal to RA equal to 0.667, which is the RD value, and equal to 1, as we've been seeing the 1 unit load is upward, and in this case we will calculate the RA value, which is 0.33, which is also downward. So our first task has done, which is the find the reaction on the wall member, wall trusses, which is real force, and the virtual force. The two types of we can calculate the reaction. This is the reaction, This is the reaction for real forces. For the virtual force diagram, we have been calculating also this reaction. Now second, we can see the find the angle. So I will calculate the angle. So this is the nothing but this is the angle theta. As we know the tan theta, this will be tan theta into length, height into length. So height, we have been know the 10 feet is given here. This is the 10 feet. This is the 10 feet is given in here, and length is also 10 feet is here. So 10 into 10, so angle will be 45. So this is the 45. Okay. So let's see. So we are getting the I'm just changing color. So we are getting the this angle 45. This angle and this angle also remain same. So now we'll see the real truss. How we'll find these forces. So at first I know that the forklift load is upward. So the this member will be downward. So we have to must be it will be keep in mind for calculating in very quickly. Otherwise you have to take the more times. So as you have been seeing the here 4 kp is upward. So what will be this member? This member will be also downward. I will calculate. So let's see at first left side, which have been given is 4. So 4. So we assume that this 4 is upward. So it will be called the reaction will be downward. So like this downward. So if we calculate that this member downward, so there is a 2 component. One is vertical, another is horizontal. Okay, so this member we have been seeing the two as the inclined member. So it will be component. It will be divided two by one is vertical, one other is horizontal. So as we been the vertical member is 4, so that's why we are taking the vertical member. As we know, this is the theta, so this will be theta. So as this is the theta, then there will be as we know the theta in the arm of theta is cos. Another was there is no theta, there will be sine. So we have been seeing here 4 into 5 CA. It will be sine. Sorry for that. So as we have been seeing here, 4 is upward. FA, which is force FA in vertically, which is sine 45. As we calculate FEA is 5.6 is, as we've been seeing here, the 5.6 is in downward, so you can see minus in 5.6 is. Okay, so in this case we have been find the 5.6 is. So if we calculate the horizontal member, so as we have been finding the inclined forces, the member force FA. So if we calculate this member, so it will be opposite direction of the horizontal. How is it? So if we see here, we can see there is a 2 component. One is horizontal direction is going here, another is vertical. So this horizontal will be this horizontal, and this will be opposite. So as we know, this is the theta, it is a cos theta, and it will be also cos theta. So now we can see here FAB, this is the FAB minus FAA into cos 45. So this member FAA and cos theta. So FA, how we will calculate the FAA? In the previously we have been found FAA, which is 5.66, and putting the value 5.66 and finding the value FAB equal to 4 value. This is the 4 value. So in this case we are getting the 2 value. So we have been seeing here the finding member, which is FA 5.66, and AB we have been found 4. So we can calculate easily on other things, which is we have been seen this is the 4 is downward, so it will be goes on upward. And another we can see this joint member is going left to right, which is 4, so it will be prevent the for equilibrium purposes is right to left. This is the 4, that's why the direction is given here. So as we know that this is the direction is right to left is 4, so in this case we for equilibrium purposes we are putting here to right to left in also 4. So in the same case, similarly we can use the for joint C we can see the joint B is going rightward is 4, so preventing this force is it will be going the right also. As the symmetric cases we can use the same value, as we know that this is the 4 is upward, so it will be prevent also downward. So that's why I'm taking here I'm drawing the symbol in downward is 5.66. so this component is divided to one is horizontal, another is vertical. So this force, the 4 load will be only prevented by this vertical. So as we know this is the theta and this will be theta, so this is the opposite theta, that's why it will be cos theta, FAB cos theta in same as it is 4 minus F it will be FED minus sin 45, so FED will be 5.66 which is minus 5.6, the same value as we will found. And if we found this value, so as we know this is the theta, this is the horizontal force, and 5.6 is FAB, this means we can see FCD or DC. So FDC minus FED, so we just putting this value, then we will found FDC value which is 4, so this is the 4. And the all calculation we have been founding here for it will be downward, so the upward will be for the equilibrium purposes. And in this case all the truss member we can calculate in this way, so there will be no problem I think. So our real truss has completed, so now we can see the virtual truss how we can calculate. As we know the same thing is happened. How as we know the 0.33 is going downward, so the member will be upward for balance equilibrium purposes, that's why the member direction is given here, so put in mind. So there will be two components, one is horizontal and another is vertical. So this is the theta and this is the theta, so it will be must be sin theta. So 0.33 minus if we use this formula, 0.33 minus FAB equal to sin 45, then we will found here 4.45. But put in mind in this case we are putting here 4, but when we calculate the virtual forces, then it will be 0.33 instead of 4, but all will be same, then we'll found all the value are same as it is, same 0.45. so 0.45 will be found in this member. So if we calculate for this member, what will be value? The value will be horizontal value of the 0.45. So if we put the 0.45 is here, this is here, so it will be 0.45. If we putting the 0.4 cos 45, then you will found here another value which is 0.33 minus 0.33. So so in this case we can calculate all this value here as it is we've been shown as previously for real truss, as the same value will be found from 0.67 is downward, so it will be upward point. It will be upward. So upward we have been seeing the two component. So one is horizontal, one another is vertical. So vertical we have been it will be sin theta, as we have been seen here, sin theta FAB it will be 0.67 and FAB sin 45, and if you put in here 0.67 instead of 5, then it will be we will found another value which is 0.96 0.95. So in this case 0.95a is this member, the inclined member. So if we calculate the horizontal member, then we will found the 0.67 in this figure. So 0.67 is going in a direction D, joint D. So joint C will be in the opposite direction. So when joint C to D will be opposite, if and then in this case the C B will be opposite also. So all these things are we can calculate in the same way. I'm just skipping here. So I hope that you can calculate all things as it is in SM1 of solid mechanics 1 or the basic equilibrium formula. Okay. So now I'm going to the main topic, which is, as we've been founding all the fourth member. Now we can draw a table which is we can write the fastest member ABCD, which is going AB, then BC, this is the BC, and CD. If we take the another here, this is the CD, and DE, this is the DE, where DE this member, then EF, this is the EF, and FA, this is the FA, and FB, this is the FB, and we can see BE, here is a BE, this member is BE, and last one C is CE, this is the C, EC, this is the last one. So all the member are same. So we can see the real force, that means this diagram, and virtual force, that means this diagram. Okay, so we can denote it real force N, this is the, we can see here N, and virtual force in small n, this is the small n. So in this case FAB, so as we know, this is the AB, this is the first member. So I'm just changing color. This is the FAB, the first force. So this is the FAB, and this is the FAB. So the real force FAB we've been found 4. I'm sorry, erasing here. So 4 is here. So we're taking here 4, and the virtual work we've been founding 0.33 minus 0.33. So minus 0.3 is found in here. So in the same way we can take the BC, where this is the BC member. So the BC member is found for 4, this is the 4, and this is the found 0.67, the minus 0.67 is here, and length. So I'm just keeping here length. How we calculate the length is given here. So length is given here. So if we calculate all these things, if we multiply 3, then 3, which is n, 4 into 0.33 into 10, then we will found 13.2. If we calculate this value, 4 into 0.67 into 10, and we will found the 26.8. Well, we can multiply all this, and in this case, in this way we can calculate all these things. So after multiplying all these things, then we can sum up here. We can see another thing is BE. We can see here the B is nothing else, because this is the C, this is the BE. If we go the BE, then we can see here there is no forces. That's why this is the 0. If we multiply with 0, then it will be 0. That's why it will be void. So if we now we can sum up all this value, then we can see sum up, which is 13.2 plus 26.8 plus 26, and we can see all the minus will be, sorry, it will be minus 13.3 minus 26.8 minus 26.8 and minus 75.8, and then and in this way all the multiplies of all the adding all these values, then we will find minus 0.66, which is summation of n into L into L. So our question was determine the vertical displacement joint C. So if we go here, the vertical displacement C, this is the C, delta C equal to n summation of it will be integration means all of the summation, integration n into L. N means virtual work forces, and n equal to real process forces, as we have been seen here, and we have been taken here, and L, this is the all the multiplication, as we have been here, we have been taken here to minus 2.6 minus 246.64. So we are putting here all this value, and A, how we calculate A is given in question 0.5, and E is given 29.10 to the power 3, and putting all this value here, and found minus 0.24 or minus 0.24 inches. What does mean it minus? So as I'm just putting here, erasing here all these things as you have been shown here. So our value is minus, this is the positive value, so it will be dot line is like this. So this value minus C is in going to downward, so minus 2.4 inches is downward, is vertical deflection is occurred, so for this loaded. And this is the extra. If we find if a BC is 0.25 inches short, what does mean it? This mean it B in C. It is 10 feet. If the 10 feet is not, but it is short is 0.25, then what will be happen in the same load and same things? Then we can calculate the deflection, which is n into BC. N means which is only real truss forces member. So BC we can see here, the real truss 0.67 we've been seen here. So 0.67 is given here, and delta L equal to 0.25. So 0.25, what is the delta L? Delta is given in question 0.25. That's why we have been found minus 0.167. So it will be upward. So if the it is the short, then dot line, if I draw, it will be like this acting. Okay, another question: if AB and BC and CD temperature increase, which is 58 degree Fahrenheit. So we can see AB, BC, CD, AB, BC, CD, AB, BC, and CD. Okay, I'm just changing color for your convenience. Okay, so AB is this member is AB, and this member is BC, and this member is CD. So if the temperature increase 58 degree, then what will be happen for the case of deflection? So delta L, as we know, alpha delta T into L. Alpha is given 5.5. This is the constant value into 10 to the power minus 6, and 58 is delta T, which is Fahrenheit, is given, and L is given which is 10 into 12. So how we'll get 10 into 12, as we seen here, 10 into 12 is given here. This is the 10 feet, and it will be multiplied 12, that means it is converted into inch. So that's why we'll found 0.3 and 0.2 and 0.28. So this is our we can see it will be deflected, or it will be shorted. Now we can calculate the deflection. So what will be the deflection ABCD and DL? So it will be the virtual load plus into delta L. I will calculate delta L. Delta L is finding in previously, and if we calculate AB into delta L, AB is 0.33. It is N is taken only for virtual load. This is the virtual load forces. So AB you have been found is 0.33 here. So this is the 0.33, and it will be multiplied with this value in delta L, so we are taking here delta L. Another one we have been seen BC, which is 0.67, as we have been seen here 0.67 is here, and it will be also multiplied with delta L and 0.038. This is the another one. And last one we have been seen CD value. This is the member of CD have been is 0.67. So 0.67 into 3.38, and in this case we have been seen 0.06 and 38. It will be inches in downward, as we have been seen also here. So it will be also deflection will be like this deflection will be like this member will be deflection like this. So the summary in this case I have been seen here, the example as indent. If you have any question, then let me know. I'm just summarizing again that they determine the virtual work displacement at C. This is the point of C. We have to calculate the deflection, then what will be happen. So at first we have to calculate the at first we are taking the two diagram, which is the real diagram N and another is virtual work. When the real diagram, there is no force, there is a 4 and 4 load, and when the virtual load, then only one load is given, is one unit load, where the displacement is asked. We just put the one unit load in upward, and then we can apply the equilibrium equation for getting the reaction. For here we will find the reaction 1. So we can reaction 4 and 4, and in this case for virtual force diagram we have been found 0.3 and 0.67. And then we can calculate the theta. How will calculate the theta? This is the, we know tan theta equal to height into length, then we will find 45 degree. Then we can find the deflection, that 1 unit load, and find the member force. Find the member force by calculating quick calculation. How will calculate quickly calculation? This is the force in upward, then it will the member, this member must be act in downward, as this force is upward. In the same case as we've been seeing, this load reaction is downward, so this member will be must be opposite direction for the sake of the equilibrium purposes. Then we've been found 5.6 and 4, and all the member we've been calculating. If you I want to show another calculation here. Here calculating the another virtual deflection point B. This is the point B. This is the point B of the trusses, and due to the external load is applied and given EI is L given here. So real truss is given here. So if we calculating here, we are taking the moment is here 1. So what will happen? So let's see. So 10 into 6 into R into RC equal to 40 into 0, and in this case we will found RC equal to 50. So this is the value RC we have been found, and RA. This is the determinate structure as pin support and the roller support. So that's why we will use virtual work method. Otherwise we have to use another method. Okay. So in this case FY will found 5. This load is also fine. Now how we will calculate this member forces. If we draw here the section taking 1 1, this is the section 1 1 we are taking here. I'm just taking the snap where okay. We're taking the section 1 1. This is the section 1 1 we're taking here in right side. So if we take the 5 is we are founding here RC RA in downward, as we've been seen here. So RA is downward. Sorry, this is the 5 is given in downward. So member will be like upward. How? So let's see how we calculate. So 5 is downward. So we are calculating the theta 10 into 20 into 20. So the height into length, and founding the 45, and FAF. So this member FAF into sine 45, and in this case we been from sine AB equal to sine AF equal to 7.71, which is upward. As the load is 5 is downward, that's why it will the member is acting in upward. And in this case we're calculating the summation of f of a in the same here, and finding the FAB equal to -5 here, and the same things we calculate from section 2 to, if we calculating the section 2 to here, and finding here. So I'm just skipping all this values here. I'm not taking the section any kind of any here for the sake of the balance purpose. So we're just taking the equilibrium for fasting calculation very quickly. So in this case we have been finding here the FCD value and FD, all the value, and FDE value, which is 7.76, and after the getting all this value, and we are draw this diagram, and this is the real truss we've been seen in. And in the same way we can use the virtual truss, as we've been taking one load is at point B. After one load is giving here, the what will be phenomena, and I'm just skipping all these steps as the very lengthy, and finding this is the downward, so it will be upward. It will be upward means this force will be upward, this member will be upward. So it will be downward, that means the member force will be upward. And calculating all this value and finding it here, and putting all this value, and the finally deflection B will be from 0.01, which is plus, this means positive, it will be 0.01. Okay, thank you everyone. If you have any question, then let me know. I will showing again and again.